week from today, I know,
What?
is the day we will have our next test. 30 questions must be done in class.
Michael, would you pass this back, please?
30 questions must be done in class, no notes, no help. And it'll be on stuff that you've done and stuff that you haven't done, okay? 50% or higher is where I want you to be. As a class, we are at 68%. Today, I'm going to be working on the end of Module 2. And when I get down to the end, make sure you don't trip, please. When you get down to the end of Module 2, that's kind of, y'all are, some of you are ahead of me, some of you are behind me. But if I look at the numbers, the beginning of Module 2, y'all were in the 90s, some are in the 80s, but then when I get to the end of Module 2, I see the 30s and the 40s and the 50s and the 60s. So this is what I'm getting ready to go over right now, the end of Module 2. And then we'll be ready to go over geometry and finally integers. Geometry is kicking some of y'all's hinds. So, Module 2, the end of Module 2. Where we left off was talking about is over of and part over whole off the formula sheet, and you will be able to use the formula sheet on your test. I'll just give you that yellow formula sheet versus you having the purple one. Now, let me go back to the formula sheet for just a second. So when we left last time, we were looking at this, where we had the is over of and we had the a over b. And we needed to be able to recognize, are we using is over of or are we using a over b? And I told you that is over of is when you have that short, cute little problem. 5% of 20 is what? And if it's a bigger problem, it's usually going to be the a over b. So for this problem, you have a file that's being downloaded. 15.4% is complete. How many has been downloaded? What kind of problem is this? Are we talking about leaving a tip? Does this problem talk about leaving a tip for a meal?
No.
Is it talking about a commission? Is it talking about discounting something? Difference of two things. Tax. This is going to be a part and a whole. Part over whole equals percent over 100. Easiest thing to look for is the percentage, 15.4%. Now, what do we have to decide? We have to decide 278. Is that the whole file or is that the part of the file? A file is 278 that's going to be downloaded. So when you're watching your computer and it says this is being downloaded, 278 is the whole file. I want to know what part has been downloaded. So 278 represents the whole entire file. I want to know what part of that 278 has been downloaded. You with me? 278 is the entire file. I want to know what part has already been downloaded. And then I am going to cross multiply. I multiply the two numbers that are diagonally across, and then I divide by my loaner. So I'm going to multiply these two numbers and then divide by my loaner. So in my calculator, I will do 278 times 15.4 and then divide it by 100. Now, it will suck if you get this far and then miss it. It says round to the nearest tenth. Your tenth spot is the first place behind the decimal, so that is going to be 42.8 has already been downloaded. 42.8 has already been downloaded. We good? 42.8 has already been downloaded, and I'm gonna do several of these, just to get you back in that drift. All right, let's look at, let me do a tip one. I don't think we did one of these last time. This one is talking about leaving a tip. When you go out to eat dinner, leaving a tip. So this is tip over meal equals percent over 100. Tip is your A, meal is your B. Now, my percent is 15. Your percent is always over 100. The dinner bill, which is your meal, is $89.23, but it says first round that bill to the nearest $10. So your $10 is going to be here. So what does that round to? 90. So not only did we have to put the meal in, we had to put the meal in to the nearest $10. And it says estimate the tip. So we're trying to figure out what the tip is. So what would I do in my calculator? 90 times 15 divided by 100. 90 times 15 divided by 100. So if you go out to eat a $90 meal, or an approximately $90 meal, and you want to leave 15% tip, you're going to leave a $13.50 tip. Do what? We good? So this one little chart right here, you're doing the same thing over and over and over again. Look at this one. An international company has 14,900 employees in one country. If that represents 32.4% of the employees, how many does it have in all, in total? Which one am I going to use?
Percent. You talking about the whole?
Which one of these am I going to use? The part and the whole. Part over whole equals percent over 100. There's my percent. Now, what does this represent? My part or my whole?
Oh, that represents the whole 14,900.
A lot of people think 14,900 is a big number, so that's going to be your whole. But 14,900 is just how many employees are in one country. I want to know how many employees are in the whole world, or how many employees are in the whole company. So, if this is the world, 14,900 are how many in that one country. I want to know how many are in the whole world. So 14,900 just represents the part that are in one country. I want to know how many are there in all, in the total, in the whole. So when I go to my calculator, 14,900 times 100 divided by 32.4. Now, some of y'all will get this far and still miss the problem because it says round to the nearest whole number. We're talking about people, so we can't have point something of a person. Whole number. The 6 tells the 7 to do what? 45,988 would be your final answer because you can't have part of a person.
Okay.
All right, hold on. There's 2 more that I want to bring up. I want to bring that one up. And I want to bring this one up. I think that's it. Okay. The price of technology has dropped to $9.58 today. Yesterday's price was $9.69. find the percent decrease. Okay? This is not talking about a tip. This is not talking about tax. This is not talking about discounting an item or commission. When you hear the problem say percent increase or percent decrease, you're automatically going to do this one. So if it says find the percent decrease, or if it would have said find the percent increase, you're gonna automatically use this one right here, difference over original. Now, when I come around and explain it, I don't really call it difference over original. I'll tell you what I call it in just a second. What's another name for difference? If I tell you to find the difference between two numbers, what am I telling you to do? Subtract. So I usually call it subtract. And original. If something happened today and something happened yesterday, the original is the one that happened first. Which one happened first, today or yesterday?
Yesterday.
Yesterday. So instead of difference over original, I say subtract over yesterday. It's still the same thing because difference is the same thing as subtract. And original is what happened originally. And originally is what happened in the past. So what they want you to do is they want you to find the difference, which means they want you to subtract. So to do that, you're going to take the two prices and you're going to subtract them. That's going to give you 11 cents. The original is the one that happened first. This happened today, this happened yesterday. So the one that happened first is going to be the one that happened chronologically first in time. And because it says find the percent, you're going to be finding the percent out of 100. We're going to do our cross multiplication. So it's going to be 0.11 times 100 divided by 9.69. Now, when you get your final answer, it says round to the nearest tenth. So my answer would be 1.1%. Now, it doesn't matter if you're doing percent increase or if you're doing percent decrease. You do the same thing. This just happened to be a decrease because the price went down. Now, they get boring problems in the book. And I have a lot of people saying, when are we ever going to use this crap? This crap is used all the time, okay? For example, if you go buy a drink and they decide to change the packaging of a drink. So you go back to the store and let's say the drink bottle, let's say the drink bottle looked like this. And you go buy a Pepsi or a Coke or whatever and it's 16 ounces and that's what the drink bottle looks like. And they decide to make it look all crazy. And they make it 18 ounces. And they're going to charge you a whole lot more money. But they're not going to write on the bottle, oh, it's 2 ounces more. I mean, 2 ounces is not even a swallow. Okay? It's not even a gulp. So what they do is they calculate the percent increase, which is subtract over original equals percent over 100. So my subtract is how much it went up or how much it went down. So 18 minus 16 is 2 ounces. It went up 2 ounces. What was the original? What was the original size of the bottle? 16. And we want to know the percent that it changed. So when we come over here, we're going to do our cross multiplication. So we're going to take 2 times 100 divided by 16. So we can legally, mathematically say that the bottle is 12.5% bigger. This gets my mama all the time.
It sounds big.
It sounds bigger than 2 ounces. They'll put on the label, now, more than 10% larger. They won't say 12.5 because that sounds petty. They'll say more than 10% bigger. It makes you sound like you're getting a whole lot more, but you're just getting not even a shot glass size. I mean, you're getting a tiny bit. You're getting a sip. Okay? I do this all the time when I go shopping. If I go to TJ Maxx or somewhere like that, and it'll have on the receipt, I mean, on the little tag, it'll say, was $49.99, now $19.99. On the way home, from Florence to Hartsville, I drive and I say, is it better to tell my husband that I saved $30? Or is it better to tell him that I saved a certain percentage?
$30 sound good.
Probably
Watch
say you
this.
spent 20 bucks.
I want to know the percent decrease because the price went down. Okay? Subtract over original, percent over 100. So my subtract is how much the price changed. So it went from $49.99, and we're going to subtract the the new price, and that's $30. What was the original price? $49.99. And we want to know the percent out of 100. So pull out my little calculator on my phone, and I do 30 times 100 divided by $49.99. I saved 60% off of that item. So I just got to say, okay, is it better to say it was $30 off, or is it better to say it was marked down 60%? Because mathematically they're the same thing. I just got to say which one sounds better. So I'm using the same marketing technique that Pepsi's using when they say 2 ounces or 12.5%. That is percent increase and percent decrease. Subtract over original, and you only use that when it says percent increase or percent decrease. All right, here's another one. It says we want to know the tax rate. So this is talking about sales tax. So we're going to do sales tax over purchase equals percent over 100. So we're buying a camera, so that's my purchase price. We're purchasing a camera for $597.95. If the tax rate, and another name for rate is percent. So if the tax rate is 9.5%, okay, I'm out of numbers, which means I'm trying to find the tax. So I go to my calculator, I do a little cross multiplication. So it's going to be 9.5 times 597.95 divided by 100. So that answer represents my tax. Tax is money. Money is 2 places behind the decimal. So this is $56.81. Now, if you type that into Alex, it's going to be wrong. Because the question says find the total cost of the camera with the tax. They didn't say what is the tax. They said what is the camera and the tax. So the total cost is going to be the camera plus the tax. So we had to walk out paying the $597.95 plus the $56.81. And don't tell me, oh, you know what I meant. If you go to Walmart and buy this, and you say, oh, I'm going to walk out and only pay this, you go into jail. They want to know the total you paid when you walked out. So when I go and walk out the door, I'm going to pay the $597.95 plus the $56.81. There's my final answer. That is your total cost. So you had to find the tax and add the tax to the price. Now, if the question says, what is the tax only? Then your answer would have been 5681. And anytime you're dealing with money, you only go 2 places behind the decimal. Cool? All right. Now, we're going to get away from A over B and is over of for a minute. We're still going to do some percentages. But notice that every time I did an A over B or an is over of, my percentage, I did not whoop whoop. If it was 9.5%, I plugged in 9.5. Because this is really my whoop whoop. So if you are using this or this, you leave the percent as is. So if it's 9.5, you plug in 9.5. If it's 15%, you plug in 15%. So if you're using one of those formulas, you leave the percent as is. Now, for these last few pages, I'm not going to be using those formulas. So if I'm using my percentage, I got the whoop whoop. So anytime I get away from a formula, I've got to change my percent to a decimal. So for these, I'm not using is over of or A over B, so I've got to whoop whoop. So I need to whoop whoop. I'm changing my percent to a decimal. So which way do I move my decimal? To the left, to the left. So I'm going to the left, so it's going to be 0.031. You with me? So to get part A, I'm going to do 0.031 times the 43,000. I'm going to whoop whoop the percentage and multiply. If you're not using is over of or A over B, you've got to whoop whoop the percentage. So I whoop whoop my percent and I multiply 0.031 times 43,000. That's going to give me my first answer, 1333. Now, what does the word decrease mean? Subtract. So if this says decrease, that is telling us that we are going to subtract the dollar answers. So to get the next answer, we're going to take our dollar and subtract our dollar. So it's going to be 43,000 subtract 1333. And the reason it's subtract is because it said decrease. So we take the dollars in the problem and the dollars in part A, and that's going to give us part B because it said decrease. So it's going to be 43,000 minus 1333. And the only reason I'm subtracting is because it said decrease. My answer to part B is 41,667. So I whooped and multiplied to get part A. Because it said decrease, then I subtracted my dollars and my dollars to get my second answer, girls. Now, for part B, same kind of question. When I whoop my percentage, what am I going to get? 0.148. I multiply it by my dollars, and that's going to give me my first answer. Now, this time the word says increase. So now I'm going to add whatever this answer is to the 49,000. So you're still going to do the same step for part one. You're going to whoop and multiply. But because it says increase, you have to add now instead of subtract. So it's going to be 0.148 times the 49,000. That's part A's answer. Then I'm going to take the dollars plus part A, and that's going to give you part B's answer. So part A is 7252, and then I'm going to do 7252 plus, and then that's going to give me part B's answer. That's part B's answer, that's part A's answer. You've got to pay attention though to the increase and decrease, because that will get you in a heartbeat. Cool? All right, I'm gonna come back to these for a second. I wanna do the, simple interest. First of all, do we know what interest is? Explain to me, just like in your words, what does interest mean? Add on.
It's like tax in a way.
Sort of, kind of like taxes added on.
It's the amount you pay over time for
Like
having.
PD loans.
If you're broke and you have no money, and you need to borrow money to buy something, they are charging you daily, monthly, yearly, however, they are charging you to let you borrow money. That's what interest is. So if you have money, you don't have to worry about interest. Now, when I had my child, I wanted Madison to learn about good interest. So when she was 3-4 weeks old and just got her Social Security card, I opened her up a savings account. And my baby daddy was like, "What are you doing?" Every time I got a gift card back or a rebate back or a little money that I didn't know that I was getting back, I put in a savings account for her. Because when you have a savings account, instead of hiding money under your mattress or hiding it in a shoebox, if you put it in a savings account, they give you money back. That's good interest. So Madison will be 13 next month. She has almost $5,000 in a savings account. Just from me putting a little bit here and a little bit there, you know, not too much over time, but she gets every month, and she knows it's there, she gets a little bit every month of good interest just because she has money in the bank that she didn't know about. Now, had I not done it when she was little and I said, "Oh, I'll do it later," she would have already been 5 or 7 or 9, or I still would have been waiting to do it. So, you know, if you have children, you need to start off young and just put, you know, when they have a birthday when they're 1 and get money, they don't need that money. Put it away.
And mine have a Roth IRA account.
Yeah, Roth IRA, same thing. You're putting away money and saving it, and she knows she has this money. It'll go for when, you know, and sometimes she'll come to me, "Mama, I really want blah, blah, blah." I'm not paying for it. You know, you can use this money, but this is your money. You know, for college, for a car, for whatever. But I want her to learn about good interest as well as bad interest. So, there's 2 types of interest. Simple interest is like a one-time interest. I'll let you borrow this money, but pay it back with me and owe me $20. There's just a one-time interest. That's simple interest. Now, on your formula sheet, you do have a formula for both types of interest. It's right up underneath the I is over of and the A over B. So, we're going to start with the simple interest formula right here. Now, in the simple interest formula, the P stands for the money that you're borrowing or the money that you're putting in the bank. The R stands for your percent, but you've got to turn it into a decimal, which means you've got to whoop it. So 2 to the left. And T stands for the time that you're going to leave it in the bank or the time that you're going to pay back the loan. So for this problem, $800 is what we're borrowing, or $800 is what we're leaving in the bank. So our P, our money, is going to be $800. 3%. 3%, if we whoop that, that is going to be 0.03. We are leaving it there for 4 years. So to get our interest, we are going to do 800 times 0.03 times 4. So if somebody gave us $800 for 4 years at 3%, we would have to pay them back the $800, but we also would have to pay them back an extra $96 in interest. So we would have to pay them a total of $896 back. The $800 we borrowed, and $96 because they were nice enough to give us money when we were broke. Does that make sense? All right, let's do one more of these. These are not that bad. This time, $200. That is gonna be our principal.